So hopefully you watched the warm-up video, and if you did, then you've pretty much already done this whole lesson, so it shouldn't take very long, okay? So this time we're going to talk about splitting things up, simplifying cube roots and fourth roots, which just means we're using bigger roots, okay? So now this time, instead of breaking up our numbers into square roots, I'm going to be breaking them up into cube roots, all right? So this is where it gets tricky. If you don't know your cube roots, you got to learn them. All right, so I'm breaking this up into 108, and that gives me 27 times 4. Okay, from there I do my exact same steps that I did before. I split my cube roots. Okay, so cube root 27 times cube root 4. I take the cube root, which gives me 3, times this unsimplifiable cube root of 4, and that leaves me with my answer, 3 cube root of 4. So I have to look at my root to figure out whether I'm looking for perfect squares or perfect cubes or perfect fourths. All right. In this case, I look at my root and I see, oh, I'm using 3. So that means I'm looking for perfect cubes within the number 128. Okay. So a perfect cube that I know of that's in 128 is 64. All right. So I'm going to rewrite this as 64 times 2. All right. So now I can break it apart. Cube root of 64 times the cube root of 2. All right? And then when I take the cube root of 64, that leaves me with 4 times the unsimplifiable cube root of 2. And that is my final answer. There's nothing to multiply it by on the outside. Okay? Now, if you're still struggling with finding what numbers make perfect cubes, all right, or figuring out what perfect cubes are in the number, this time, remember we did a factor tree last time, all right? Instead of looking for pairs of numbers, we're looking for sets of 3, okay? So let's break 128 down. Let's think about really easy numbers to divide by. So let's just do 2. 2 and 64. Now, assuming you don't recognize that that's a perfect cube, we'll just keep going, all right? So divide by 2. That will leave me with 32. I can divide by 2 again, and that leaves me with 16. Divide by 2 again, gives me 2 and 8. Divide by 2 again, I get 4. And finally that breaks down into 2 and 2. All right, so now that I have everything written as the simplest prime factor, I'm just going to try to pull out any sets of 3 that I see. So I have a set of 3 there. I have a set of 3 there. And I have one lonely 2 left over. So I'm going to rewrite that. 2 cubed times 2 cubed times lonely 2. All right, and if you want to write it as perfect cubes, you can say 8 times 8 times 2. And now that we have found all of our perfect cubes, we can go ahead and throw it back under the radical. So 8 times 8 times 2, break up the radical. Okay, notice how I put the 3 every single time. All right, cube root of 8 is 2 times cube root of 8 is 2 times the cube root of 2 is the cube root of 2. All right, now I got to simplify these pieces, so I get 4 cube root of 2. Okay, so that's that first part. If you need any of that again, just rewind and watch it again, okay? Now, let's go to the second part, working with the variables, okay? My first step here is to decide what I'm dividing by. Okay, remember with the variables, you're going to end up dividing the exponents by the root. Okay, so with this x to the 17th, I'm going to be dividing by 3. So that means I'm looking for multiples of 3, the closest multiple of 3, as close as I can get to 17. All right, so that's x to the 15th. 15 is divisible by 3. The next one would be x to the 18th, which would be too big. When I pull the x to the 15th out of my 17 x's, that leaves 2 behind to be in the other group. I split my radicals. I take the cube root, which means I'm doing 15 divided by 3, and that gives me 5, so I get x to the 5th. All right, and then this x squared, it doesn't simplify now because it's a cube root. Okay, it's not in a group of 3. So this is going to stay the cube root of x squared. Okay, so let's do this other example together now. All right, first things first, decide what I'm dividing by. I am dividing by 3, okay? All right, so that means I need to break x to the 12th up into multiples of 3. Well, great news. X to the 12th is already a multiple of 3. So I just have to do 12 divided by 3 equals 4. So that's going to be my exponent here. Okay, so my final answer is just x to the 4th power. Okay, so there's some practice on the back. I'll run through a sample problem or two. All right, let's go ahead and just try, let's try 11, just for kicks, okay? So I have a number outside. Remember, I'm going to hold on to that until the end, and it'll just be multiplied, so we'll get there in a second. All right, so this is 6 cube root 8 xy 9. Okay, and this is a 3. All right, so my 6 is going to stay out here, and let me change what's happening here. So I need cube roots, so I'm looking for perfect cubes. 8 is already a perfect cube, so that's great. All right, times x, okay? X can't be simplified at all. I'm looking for sets of 3, and there's only one x, so I can't do anything to it. All right, and y to the 9th, that's super awesome because that is a multiple of 3, which means when I take my root, I'll be able to divide evenly by 3. Okay, so now we get 6 times cube root of 8 times cube root of x times cube root of x to the 9th. So let's simplify everything we know, okay? The 6 is going to stay. The cube root of 8 is 2, and the cube root of x to the 9th is x to the 3rd. I'm just doing 9 divided by 3, okay? So 9 divided by 3, which is with x to the 3rd, and then I have this unsimplifiable cube root of x. So now to finish the problem up, I'm just multiplying here, here, and here, which gives me 12x to the 3rd times the cube root of x. And that's it. That's the answer. Okay? So, if you're struggling with this, rewatch some of these videos, and I wish you good luck on your quiz at the end of class. Okay?